I'm quiet. Hungry.
Hello, everybody. We are doing 3.3 day 1 today. Hopefully you're making today happy. So this is a new concept to all of you. Find the domain. I feel like we've talked in the past that domain is X and range is Y, but we've never looked at an equation and had to identify the domain. So this is kind of new. The domain is all possible values for X that you could put in a function and get a real number out as your solution. We want to stick with real numbers as our solutions today. All right, so let's try our first example problem. I've got f of x equals the square root of x. This is my function, and I'm going to figure out my domain. I simply say to myself, if I want my answer to be a real number, what type of values of x should I put in? So I'll take you through what I question myself. So I question myself, can I put a negative number in for x and get a real number solution? No. Can I put a 0 in for x and get a real number solution? Yes. You can square root 0. Try it real quick if you don't believe me. You can definitely square root 0 to the answer 0. And then, can I square root a positive number and get a real number solution? Yes. So basically our domain is all numbers from 0 on up. Do you agree? Let me show you that on the number line. My domain is all numbers from 0 on up, right? What number lives way out here? Infinity, right? Someone said 10. Infinity. Infinity lives all the way up there forever. Okay. So here's how we're going to write that. Our domain is all numbers from 0 through infinity. That's how I'm going to write it. So it's like a range. Now this is going to be weird. I'm going to put a parenthesis on infinity, and I'm going to put a bracket on 0. Here's what the bracket means. The bracket means include that number. So include 0 in the domain. Sometimes you're not allowed to include 0 in your domain. For example, you're not allowed to divide by 0. But if you're including it, it's a bracket. And I don't know why they don't put a bracket on infinity. Probably because infinity is not an actual number that you can include. It's a concept of forever. This is how they do it. It's how, if you take calculus, that's how they'll do it. Take pre-calc next year, that's how they'll do it. All right, let's head over here. My function is f of x equals 4x squared. Can we put negative numbers in for x and get real number solutions? Yes. Can we put a 0 in for x and get real number solutions? Yeah. If I put a negative in, though, my answer will be a positive number. But yeah, negative numbers are real numbers, yes. And then if I put a positive number in, would I get a real number as my solution? So I can put everything in, right? This is what it would look like on the number line. I can put everybody in. What number lives way down here? So basically, I can put any number from negative infinity up through infinity in for x. So that's what the domain is. Negative infinity through infinity. So writing it like that basically means all real numbers. And have you ever seen all reals written like this? Yeah. Yes or no? If no, just be aware, if I would write this in the board, that would mean all real numbers. It's like a R with like a double bar. I didn't invent that, it just means all reals. So negative infinity through infinity has the same meaning as all reals. All right, next function is f of x equals 5 over x minus 9. So let's brainstorm a little bit about division. What do you guys know about division? What are you allowed to do with division and what are you not allowed to do with division? Can you divide by a negative? Can you divide by a positive? Can you divide by 0? cannot divide by 0. So I had somebody in my last class tell me the domain would be all real numbers except for 0. And I said, 0 would be fine. If I stuck a 0 in for x, my final answer would be 5 over negative 9. That would be fine. It can't be 9. You're right. The way I'm going to write that is I'm going to write all reals except 9. Because 9 is the number we would want to avoid putting in for x. Now that's not how they would do it in calculus. Do you guys want to be scholars and see how they would do it in pre-calculus and calculus?
Sure.
But some of you are very scholarly in this class. They would write it negative infinity through 9 and then 9 through infinity. Now notice how I'm using parentheses because we're not including 9. Then they would put a U in between. They would union these two sets. The U would go in between. I'm just kind of out of space. Let's see if I can make that look nice. Not gonna let me move it over, but the union would go smack dab in between the two sets like that. So, since we're only in Algebra 2 and we're not in pre-calculus or calculus, I would accept this answer. This is for these scholarly people that want to see it. All right, in part D, our function is f of x equals 8 times x to the 1/2. How could I rewrite 8x to the 1/2 with radicals? Do you know? Do you remember from last week? 8 times the square root of x. Right, because the denominator can become the jail guard of the variable. So I rewrote it so we can think about it easier. Can I square root positives? Can I square root negatives? No. And can I square root zeros? Yes, so 0 through infinity is our domain again. It's always going to be your domain if there's a square root, a 4th root, or a 6th root, or any even root. Hello.
Why could it be something like -1?
Why can't you square root -1? You'll get an imaginary answer. Try it. Try typing in square root of -1. The answer is
Why would we
1i. Why would you square root x? Oh, because x to the 1/2 has the same meaning as square root x. Let me pause this real quick. All right, let's see what's up next. This is a chart you don't need to write it down, but it's going to show you what's coming. Basically, we're going to be taking two functions, function f, function g, creating a brand new function by adding them up, maybe subtracting them, maybe multiplying them, maybe dividing them. We'll be doing all four of those things today. But then getting an overall answer that we will then look at and try to determine the domain. So just keep in mind you can't square root negatives and you can't divide by 0 when you're thinking about your domains. All right, so this is what a typical problem would look like. They are going to define a function f. They are going to define a function g. And then they're going to say to find this answer, f plus g. So we'll take them and add them up. So I'll probably use some colors on this. I'll make one pink and one blue. It's a plus, yeah, no, it's real light. Do you want the lights turned off?
Yes.
All right, so I'm going to circle function f in pink. I'm going to circle function g in blue, because what they're having us do is add function f with g. I'll make my function f my pink one, 4x to the 1/2. I'll make function g my blue one, and we're adding, I'm adding -9x to the 1/2. Are these like terms or not?
Yeah.
And I always joke about apples. So I have 4x to the 1/2, and I'm adding -9x to the 1/2. They are like terms. So just think about it this way. If you have 4 apples and you're adding on -9 apples, how many do you have? -5 apples. So this is the solution to part A. Absolutely. So I'm actually going to rewrite it that way. Lexi said that is the same exact thing as -5 radical x. And I agree. And I'm doing that because in part C, they are asking a domain. So you might as well just do it right now. So what is the domain of something where I'm using a square root of x? We've seen 2 of them so far today. 0 through infinity. Good. And I'm going to put that bracket around the 0 because we are including the 0. So that's technically your answer to part C. It's our domain of f plus g. Kylie?
How do you know like when to include the number to put the bracket?
If you're allowed to do it or not. So we are allowed to square root a 0, so include it. But that one where we didn't include 9, we were not allowed to divide by 0, so we didn't. Do you want me to go back to that real quick?
Yeah.
Let me pause this. Alrighty, we're ready to do part B. We're going to take function f, which is our pink one, 4x to the 1/2, and we're going to subtract off function g, which was our blue one. So what just happened? Oh yeah, 2 negatives make a positive. And then, of course, these are still like terms, so how many x to the 1/2 do I have? 13 x to the 1/2. So that's your answer to part B. I'm going to use the Lexi method, I'll call it, to rewrite it. What would it look like, Lexi? 13 radical x. So what would our domain be? Yeah, so it just happens to be the same. Oftentimes they are going to be the same when you add versus when you subtract. There's a lot of adding and subtracting of like terms today and just thinking about the domains of your answers. Six more minutes. We got this. Yep. Mm-hmm. We'll do one more. You good? All right. We'll do this as our last one. So we are going to take our functions and multiply them this time. So function f will have be pink. Function g we will have be blue. And we have to multiply. So f of x times g of x would be 6x times x to the 3/4. Now please keep in mind this 6 is not married to this x. There's technically a little dot in here. So technically I have 3 things being multiplied. Do you agree? Let's think about our exponent rules. This has an exponent of 1. This has an exponent of 3/4. What would I do to combine them? Multiply or add? Add. And what is 1 plus 3/4? It's 1 and 3/4, but how could I write that as a, with the bigger number on the top? Improper fraction? 7/4. Good job. So that's your answer. I would probably write it as a radical, because that can help me think about my domain a little bit better. It would be 6 times the 4th root of x to the 7th power. So I mainly wanted you to be aware that we are 4th rooting x. Do you remember anything I've told you in the past about even radicals? You can't do an even radical of a negative. You can't do a square root, a 4th root, 6th root, 8th root, etc. of a negative number. So that means our domain must be the positive numbers. 0 through infinity. So it's the same exact domain had it been a square root. And our last one we're going to have time for. F of x divided by g of x. 6x on the top. X to the 3/4 on the bottom. Keeping in mind the 6 and x aren't actually attached to each other. I have a song for this. Do you remember? You guys are my best singing class. Bigger minus smaller, put the answer where the bigger live. So 1 minus 3/4. Can you do 1 minus 3/4 in your head? 1/4. And that answer would go in the numerator because that's where the bigger one had been. That's your answer. As a radical, it'd be 6 times the 4th root of x. And that means our domain is the same exact thing. 0 through infinity. I'm going to go ahead and click pause. So you can... All right, we're going to do one last problem here. These time our functions are 2 terms apiece. So this is going to be something a little different. Go ahead and we're going to circle our f function in pink, our g function in blue, and we're going to add f of x plus g of x. So 2x to the 1/2 plus 3x to the 1/5 is getting added to 4x to the 1/2 minus 7x to the 1/5. Now, no need for parentheses to isolate f from g because we're just adding here. Go ahead and add together your like terms. 2x to the 1/2 and 4x to the 1/2 are like terms, making 6x to the 1/2. And then 3x to the 1/5 minus 7x to the 1/5 would be a negative 4x to the 1/5. So that's your answer. If you want to write it as a radical, it'd be 6 times the square root of x minus 4 times the 5th root of x. Now, 5th roots are awesome. When you are doing an odd root, you can put any value in for x that you would want. But the fact that we have to square root x as well is going to limit our domain to only the positive numbers, including 0. So our domain would be 0 through infinity. All right, I'll let you write that down. I'll shrink my work a little bit to make space for number 2. Number 2, we're going to take function f, which is 2x to the 1/2 plus 3x to the 1/5, and we're going to subtract off function g. Now notice, I am using parentheses right now, aren't I? That's because we're subtracting off a quantity that is more than one term. Our negative will have to distribute to everybody. So it will become a negative 4x to the 1/2, but it will become a positive 7x to the 1/5, because a negative times a negative is a positive. These two are still out front and still the same as they've always been. All right, like terms, 2x to the 1/2 and negative 4x to the 1/2 is negative 2x to the 1/2. And 3x to the 1/5 with 7x to the 1/5 is 10x to the 1/5. There's your answer. If we want to write it with radicals, it would look like this. Negative 2 times the square root of x plus 10 times the 5th root of x, which makes my domain the same as it was on the last problem. 0 through infinity. Again, because of the square root. Well, thanks for joining me today for the YouTube video. Here is your homework. Make sure you're showing all your work because this assignment is from the book and we want to make sure you are doing it yourself. See you guys later.